all waves have certain properties, whether they're transverse waves or longitudinal waves. They have certain parts or certain characteristics that is important to know these terms and to be able to label them. So, one of the things that a wave has is what's called an amplitude. The amplitude is the maximum displacement of each particle. Okay, so if we go back to the wave animation, you can see here is a wave with a low amplitude. Okay, the particles are not displaced very much, they're not bouncing up and down very much, versus a wave with a high amplitude, where the waves are jumping up and down. And it's important to notice that when you actually measure the amplitude, what you're measuring is from the zero axis to the top or to the bottom of the wave. So that's the amplitude, what's labeled here, or I could also measure the amplitude here. It's the same thing. It's from the center line of the wave to one of the crests. And the amplitude, since it's just a distance, the units for amplitude are simply meters, because we're just measuring a distance. Another feature of a wave is its period. The period of a wave is the time it takes for one complete cycle. So how long does it take a particle to go from its maximum displacement to its minimum displacement and back down to its maximum displacement again? And since the period is a time, it's simply measured in seconds. Now, a lot of times it's convenient to use the inverse of the period, which is called the frequency. So the frequency, which is the letter F, is equal to 1 over the period. And by the way, period is usually represented by the variable capital T. So frequency is 1 over the period, which means it's how many cycles per second the wave goes through. Okay, so we can look at a low frequency wave, which looks like this. Okay, you might say it's moving slow, or there are fewer cycles per second. There are fewer waves going out the window per second, versus a high frequency wave, where there are many cycles per second. There are many more waves going out the window per second. So it's not actually measured in seconds because it's cycles per second, so the units for frequency are 1 over seconds, which is the same thing as writing an inverse second, or seconds to the -1, and there's a special label for that, which we call hertz, or Hz. Okay, so to say that a wave has 50 hertz, or a frequency of 50 hertz, means that it is going through 50 cycles per second, 50 waves per second. That's frequency. Another important measurement of the wave is called the wavelength. The wavelength is the length of one complete cycle, or the distance from crest to crest or trough to trough. So it's the length of the wave's cycle. So we could draw it here. This is the wavelength. And the symbol for wavelength is the Greek letter lambda. I could also measure the wavelength here, from here to here. This is one wavelength. Or I could go from center to the next center that represents one complete cycle. So this is also one wavelength. So the wavelength is the distance for one complete cycle, or the distance from crest to to crest, or trough to trough, basically the distance or the length of one complete cycle. And again, this is just a length measurement, so it's in the standard metric units for length, meters. Finally, we have something called the wave's velocity. And the velocity we're talking about here is the velocity of the actual wave itself as it propagates from left to right. So not the velocity of the individual particles that are going up and down, but the velocity of the wave as it moves from the gear towards the window. So the velocity we're talking about is the wave's velocity of propagation. And it's just a standard velocity measurement, which is meters per second. Now, some of these variables we'll learn are related to each other in terms of if you change the period, what happens to the frequency, what happens to the wavelength, what happens to the velocity. But others are not. For example, we can look at the amplitude and see that if I increase the amplitude, the waves get bigger, there's more displacement of each particle, but they're still moving at the same speed and there's still the same number of waves going out the window per second. So the frequency didn't change. So amplitude is independent of the other variables, while frequency, wavelength, and velocity are linked.